Hello everyone, today we are going to solve increasing order search tree problem. So in this problem we are given a root of a binary search tree and we have to rearrange it in order. In order means the space complexity should be constant so that leftmost node in the tree is now the root of the tree. Okay, and every node has to be left child, only one right child. Okay, no left child and only one right child. So yeah, this is a new BST. Okay, so what we have to do actually is we have to convert this BST into the increasing order search tree. Okay, so this is also a BST because it's follow the properties of that left child is smaller and right child is greater. Okay, all right child are greater and there is no smaller child in the left side. Okay, so there is no left child. So how we are going to do it? So before going to the intuition, first understand key where it is the smaller element. Okay, so this is our root. So the all element here will be lesser than root and all element here will be greater than root value. Okay, so we have to first go to the lesser element, then our root, and then the greater element. So first we have to go to the left, then we have to go to the root, and then we have to go to right. So what it is in order traversal. This is in order traversal. Okay, so how we are going to do it? Let's just find dry run here. So first we go to the left. So here, then it have also left child. Then go to left, and it have also no. It don't have any left child. So first of all we find one. Then we go to right child. Okay, right child is there is no right child. So then we move to our one is done. Then we move to two. Okay, so left is done. So first we mark 2 and then we go to right child. There is no right child, so 2 is done. We go to 3. Left is done, so we first mark root and then we go to right child. So right is 4 and then right after right we go to this whole is done. Then we move to 5. We mark first root. This is our root. Then go to right. So first we go to left, then root, then right. So this is the procedure. So that's how first we go to 6. We go to first there is no left child, so we go to 6 and then we go to here. So here we have a first left, we complete this last, then root 8 and then right. Okay, so this is the procedure we have to follow. So the thing is how we are going to do it, because we have to do it in order. If we do not have to do in order, so how we can do it? So the first solution we can give it, we can store it in an array. Okay, we can store it in an array while doing an in order traversal. I hope you understand what is in order traversal. I have gone through it right now. So while doing in order traversal, you can store it in an array and then create a new BST. Create a new BST using that array. That will be the first solution. But right now we not required that solution. We only required in order solution. Okay, so let's see the solution now. So this is our solution. So how we are going to do this? Let's have a dry run here. So first of all we are taking one dummy. Okay, this is our dummy node, and then we are taking our variable which is current, which will be our current node. Right now it is pointing to 0. Okay, then we are going to do our in order traversal. So how in order traversal is very simple, if you know. So let me draw our previous example. This is our example. So let's have dry run here. So we are going to in order traversal of this tree. So right now this is our root. We are going and we find that our root is not null. So we go to here, go to root left. This is not null. Then we again go to left. Then this is not null. Then go to left, and then its left is null. So we return that and comes to here. Okay. Now root left will be null. So its left will be null. Now this will be null, and current right will be root. So this is current and its right will be root. Okay, its right will be root and current equals to current right. So now it moves to our here. Okay, now current goes to 1. Okay, now we goes to current write. So current write, right now current write is null, so it return. Okay, and yeah, so our 1 is done. So we go to move to second. Okay, so second left is done, then root left make null, so we make this as null, so we remove it and we make it null. It points to null. Okay, so you can see that it points to null. Okay, and 2 points to null, and 2 current write will points to root, so current write will points to 2, and as you can see that it points to null, and current points to current. Now current points to this. Okay, now current points to 2, so we go to current write and there is no right child, so we return null, we return nothing. So we move to 3, and this is gone. So left is done, we make it null, and then we make current write as root, and right now root is 3, so we make it 3, and then it is null. Okay, and we move our current pointer to here. Okay, and this will make, and then our 3 is right child is no, so we move to 5, and then 5 left is done, so we make root left is as null. So now current right will be root, so it will be 5, and our current gonna points to this, and this is, and this points to null. Okay, so this is done. Now we are moving to current right, so this is done, we move to current right, we are here. So from 6 we go to its left is not there, so we make its left as null, and we make this as our current, and right now we have made this null. Okay, then we go to its right, and it have a left child, so we go to its left, and then we make its left as null, its left is already null, and make its current right, made its current right to root, and jump our current to here. Okay, so now this is done, so right is not there, so we move to our 8 and mark its left as null, so we mark as null, we mark this as null and join here. Okay, this is null, and make it this null, and our current will be here. Now finally we go to our right, and there is no left and right, so we just mark this as 9, and this is our current, and this points to null. So finally our in-order traversal is done, and this would be our answer. So what we have to return is, we do not have to return dummy, we have to return dummy right. So our answer will be dummy right. Okay, so this is how the BST looks like. We can remove this null. So this is our BST, and so this is our BST. So let's understand the time and space complexity here. As we can see that we are moving each and every element of BST, so our time complexity will be of n, and space complexity, for space complexity we go, our code stack will go to at max height of the BST, so space complexity will be of h. this is the solution. If you have any doubt, so you can ping me in the comment section. You can check the source and the article of this question in the comment description. Thanks for watching.